Hello, my name is Jean-Philippe Stoldt. I'm a PhD student in computer science at the University of Victoria. My co-author is Professor Jens Weber, also from the computer science department at the University of Victoria. The title of our workshop paper today is Provenance-based Trust Model for Assessing Data Quality During Clinical Decision Making. Our presentation has three parts. First, we will define the research problem and discuss current challenges with data quality assessment during clinical decision making. Then we will review a proposed solution with a novel data quality trust model and automated data quality assessment method. And last, we will discuss a practical implementation example that leverages data quality trust with an existing Smart on Fire app for the diagnosis of pediatric hypertension. We begin with defining the research problem. We decided to focus our research on three main problem areas. First, data quality assessment methods. Data quality is a critical requirement for data-driven clinical decision-making at the point of care. Research to date has mostly focused on assessing data quality of data collections, and these aggregate measures are often not suitable for data quality assessment during clinical decision-making. A new approach to data quality assessment is needed that allows users to quickly assess whether the quality of an individual data item can be trusted for a clinical decision or not. Our second focus area was on platform interoperability. Various interoperability initiatives are opening previously closed application ecosystems to enable data exchange and application substitutability. There are many advantages to building interoperability features into healthcare solutions. Our third focus area was the visualization of data quality assessment results. There have been several studies recently that showed that clinical data users were challenged by poor usability of electronic health record systems. It's important to consider cognitive requirements when designing user interfaces for new system functionality. Next, we present our proposed solution. Our data quality trust model considers a data item's provenance to infer whether a user should trust the data quality of that data item for a clinical decision. Trust in our model is based on 1. Trust in the data production method that generated the data item. 2. Trust in the individual producer that generated the data item. 3. Trust in other individuals that may have independently verified the data item. And 4. Trust in organizations that may have certified the data production method used to generate the data item. We leverage fuzzy logic to represent trust in our model. Fuzzy logic can represent uncertain variables through fuzzification. Those linguistic variables can define different labels in our model, low, medium, high, through fuzzy membership functions. Fuzzy logic also allows for linguistic computing with words. In our model, there are three different types of trusts. Producer trust in the capability of data producers, reliability trust in the reliability of data production methods, and data quality trust in the resulting data item data quality. Fuzzy inference allows for individual fuzzy sets to be aggregated to a fuzzy result set through approximate reasoning. In our model, we use the Mamdani method, which has been recognized and used widely for its simplicity in reasoning and graphical expression, also known as the min-max method. Several steps are required for fuzzy inference using the Mamdani method. They are the fuzzification of input sets based on the fuzzy membership functions, seen in the previous slide, inference based on fuzzy association rules, and the defuzzification of output sets. As you can see, the trapezoidal shapes that are resulting from this computation can be difficult to process for some computations. And so there's a conversion process to convert shapes into a crisp value by way of defuzzification. The second part of our solution addresses the requirement for platform interoperability. We leverage the fast healthcare interoperability standard to develop custom extensions to existing FHIR resources for data quality trust. Our proposed extensions are based on the current FHIR version 4.01. It involves three new value sets that define fuzzy trust levels for producer trust, reliability trust, data quality trust, and their respective trapezoidal membership functions. Extensions to the FHIR practitioner resource with new entities can be added to store trust settings for practitioner data user. For example, a new entity for reliability trust assigns trust to a data production method coded with LOINC. A more granular reliability trust assignment is possible by targeting an optional reference to a FHIR device. FHIR device contains properties for the regulatory certification status of medical devices. The data quality trust for a particular patient observation is added to the FHIR observation resource with a new field. The third part of our proposed solution addresses cognitive requirements for systems that support human decision-making. The heuristic systematic model distinguishes human decision-making in heuristic and systematic processing modes. While in heuristic processing mode, humans tend to use intuition to make quick decisions using limited cognitive effort. Lack of expertise for the decision task, time constraints, distractions are factors that can increase reliance on heuristic processing. In contrast, systematic processing requires higher cognitive effort to process ambiguous decision tasks. Individuals are not able to process all stimuli in their environment and are continuously faced with trade-off decisions about what tasks can be processed heuristically and what tasks require the additional cognitive effort for systematic processing. We've incorporated the insights from dual process theory and guidance from other scholars on cognitive user interface design in our research. The last part of this presentation covers an implementation example. To demonstrate feasibility for our trust model and assessment method, we modify BP Centiles, which is an existing open source Smart on FHIR app. Smart apps are EMR platform agnostic and they can run unmodified across different environments. Smart apps leverage the FHIR standard to connect with EMR systems. The use case is diagnosis of pediatric hypertension. Hypertension in children is a growing problem in many countries. Manual calculations on blood pressure centiles are very time consuming, so this app automates the calculations at the point of care. The architecture of the modified BP Centiles system consists of a data store server backend with EMR data and a trust settings server that are both accessible over FHIR APIs. The clinical data user interacts with BP Centiles Smart app, which is developed in HTML5 and JavaScript. We will cover modifications to 3 types of screens to support the diagnosis. For heuristic processing, this slide shows a quick view that displays the result of a data quality trust check on the 3 most recent blood pressure observations. This is the main screen that a practitioner would use for heuristic processing when they don't have the time to systematically analyze the full detailed history of blood pressure measurements or provenance of data items. If there's a data quality issue with one or more of the measurements required for a diagnosis, a warning message is displayed that advises to proceed with caution and to review detailed measurement history for any safety concerns. This warning effectively pulls the user from heuristic processing into systematic processing mode to ensure focused attention and alertness. This screen shows a detailed history view of measurements with a data quality trust filter. This filter allows the data user in systematic processing mode to filter historical observations based on data quality trust levels of high, medium, or low. This functionality may be particularly important for a high-risk clinical decision where only high-trust observations should be used. A practitioner in systematic processing mode may also want to analyze how data quality trust of a blood pressure measurement was inferred. Hovering over a data point opens a pop-up with provenance details for the measurement of interest. This slide shows the user settings screen. Any healthcare practitioner with recorded blood pressure measurements in the EMR is listed here with a sliding scale to assign a relative degree of trust between low and high. Observation methods receive a relative trust assignment as well on the sliding scale between low and high. Other healthcare practitioners that can verify blood pressure measurements are listed with a checkbox to let the user select them as trusted verifiers. Certifiers that can certify data production methods or that can report them as defective are listed with a checkbox to let the user select them as trusted certifiers. And this concludes our presentation. Thank you for your interest. We'll be happy to take your questions now.
Okay, let's go.
Hello.
Thank you so much for coming today. My name is Lina Garces. I'm the chair of this session. Okay, I'm assistant professor at Federal University of Itajubá in Brazil. And we are today with Jean-Philippe Stoldt, the first author of this paper. And please let your comments or questions in the chat. I'm reading to him. Okay. Meanwhile, I have some questions for you, Jean-Philippe. And the first one is, how do you know or what characterize that a data item is trusted in your approach?
So our method uses a provenance to determine trustworthiness of data items, and for the most part, it is based on the data source. So who produced the data item and the method that the data item was produced with. So the combination of the two, as I have outlined in my presentation, combines to a data quality trust.
So for a data item be trust, it must be produced by some certified manufacturers or software, certified software. That's right.
Yes, that's right. I mean, it's primarily based on where the data item originated, and it's right. It's provenance, and that can be, in some cases, multi-level provenance. And then there's the ability in our method to specify certification authorities or verifiers to improve the trustworthiness of a data item, where we don't have information about the direct provenance of that data item.
Okay. Elena has a question. Let me read. How do you identify which membership functions were more appropriate? Did you test several alternatives?
So fuzzy logic is quite flexible in definition of membership functions. So there's obviously a way to start with a very simple set of membership functions. Our model at a minimum assumes that we have a membership function for low data quality trust, for medium data quality trust, and high data quality trust. But that could be expanded to either very high, very low, or other kinds of labels that we associate. In our model, we've tested it just with some simple membership functions, but there are ways to generate membership functions based on user data, based on user preferences, using clustering algorithms. So that's a future expansion of our work. Right now, we've just used basic membership functions. It's very flexible in that regard.
Nice, thank you. Any other question, please? Okay. So I see in your model you categorize your between high level, medium and low levels of trust. Okay, how did you measure that? How did you gather that information? Maybe some practitioners give you some inputs to you to know how categorize the provenance of the information.
So for now, the model is generic in that regard, but depending on the use case in which our this trust model is applied, different membership functions may be appropriate. And at that point in time, based on practitioner and domain expert input, membership functions can be defined. So it's very flexible in that regard, and the membership functions need to be defined and tested and validated in every use case context before they can be rolled out in practice.
Okay, thank you. Elena asks you did you check your work with some specialists?
So we have not done that yet. Right now, we focus our research on the software engineering aspect per se, but the next logical stage would be to consult with domain experts and see find applicability in specific domain cases. We've used one clinical example for pediatric hypertension, but as I said, it has not been applied in practice yet, and so it hasn't been validated in that regard.
Okay, thank you. Any other question to the attendees? Okay. What is the future work? What is the work to do next?
The future work, well, this work that I presented today is now a few months old. So we've since done additional work around building features for verification into the model, setting different levels of trust for certification authorities and verification agents, and building a more robust foundation around the interface component. We've also looked at how FHIR interface, how the backend of actual EMR systems would need to look like, what database schema extensions would need to be in place to support a generic FHIR interface for this, so that the solution can live up to its full potential, right? Because a lot of legacy EMR applications are not FHIR enabled yet, and so showing a pathway, providing some guidance as to how those older systems can be put in a position where they can leverage data quality trust was important work. So that was our focus.
Yeah, thank you. And regarding the algorithm you selected for make the classification, why did you select fuzzy logic?
Fuzzy logic, primarily due to its flexibility and the ability to, so fuzzy logic, also known as computing with words. What that means with my research problem is that the actual method, the algorithm, is not dependent on hard coding specific associations and labels. So the method itself is flexible as to how many labels we define, how we define the membership functions, and all those pieces can be moved from a software engineering or from a coding level into more of a configuration level. So the functionality can be built into an application without having to hard code what the algorithm is that generates the output data quality trust. So again, for its flexibility and for its future-proofing it, maintainability, and also the cost of modification as new data quality trust labels are introduced, or changes to the membership functions need to be made in practice.
Thank you so much, Jean-Philippe. I don't know if you want to give some comments or for the attendees.
Well, I mean, we've showed this work in a very, kind of in a small, limited use case environment. Again, pediatric hypertension. It would be good if this work could be known more, to a wider audience. It is not limited in its applicability to a clinical use case, right? So any domain, any industry that uses data from different data providers, data production methods, would benefit from this, and the model is generic enough to be applicable and applied in those domains. So it would be nice to see it tested outside of the clinical example that we've provided.
Just one question here that came to my mind now. Besides provenance characteristic, what other type of characteristic do you consider it will be interesting to analyze the quality of the trust of the data?
Beyond provenance?
Yeah.
Well, the provenance. So one of the motivations for using provenance to infer data quality trust is that it allows for a very quick assignment of data quality trust without having to analyze the data quality of each data item individually and manually, right, for users. So based on preset settings and based on trust that's assigned to data production methods and producers, a system can very quickly, almost in real time, assign a data quality trust to a data item and can help someone who makes a decision to assess that trust in that moment, versus a lot of the other methods that are looking at data quality retroactively, that need entire data sets to compare the quality of different characteristics. So in that regard, it makes it faster, and it makes it better.
Okay, thank you so much, Jean-Philippe. Okay, if now anybody has any comment more, we can continue with the next presentation. Thank you so much, Jean-Philippe.
Thank you.